In the ancient world's civilizations, Greece's name is always written in golden letters for its devotion to knowledge and philosophy. From this very land emerged towering figures like Aristotle, Plato, and Alexander the Great. After them, in the Egyptian coastal city of Alexandria, about 3 centuries before Christ, there appeared a teacher who gave mathematics a new life. His name was Euclid, later celebrated through the ages as the father of geometry. Euclid's personal life remains wrapped in mist. Neither his exact date of birth is known, nor is there any reliable record of his family. Yet, his intellectual greatness pierced the fog of time and history to secure an enduring presence. We do know that he was associated with the Great Library and Scholarly Academy of Alexandria, established after Alexander the Great's conquests, and there he trained students who spread the science of geometry across the world. Clear and peaceful, Euclid's fame rests on his incomparable masterpiece, The Elements. Spanning 13 books, this scholarly classic served as the backbone of mathematics curricula for more than 2,000 years. In it, Euclid presented the principles of geometry with such clarity and order that they remain astonishing even today. He demonstrated that the entire field of geometry could be built upon a few basic postulates, simple truths. These 5 fundamental postulates are the lifeblood of mathematical history. The first, a straight line can always be drawn between any 2 points. The second, a straight line can be extended infinitely in either direction. The third, with any center and radius, a circle can be drawn. The fourth, all right angles are equal to one another. And the fifth, known as the parallel postulate, is the most famous and debated. It states that if a line intersects 2 other lines, such that the interior angles on one side sum to less than 2 right angles, then those 2 lines will eventually meet on that side. This final postulate became the spark that, centuries later, ignited the creation of non-Euclidean geometry, revealing new concepts of space and the structure of the universe. Euclid's true miracle was not merely these postulates, but the methodical way he organized mathematics. For the first time, he established a clear, rigorous, logical framework. First definitions, then postulates, followed by propositions, and finally, proofs. The scientific method of presenting every statement with evidence and reasoning is, in fact, an echo of Euclid's approach. For example, the standard proof of the famous Pythagorean theorem that we still study today is a gift of Euclid's logical method. Euclid worked not only in geometry but also in number theory, prime numbers, ratios, and irrational numbers. He proved that there are infinitely many prime numbers and described their fundamental properties, which remain central to modern mathematics. Writings on the propagation of light, optics, and the mathematical ratios of music are also attributed to him. He viewed mathematics not merely as calculation, but as a language for understanding the cosmos, a language hidden in everything from the movement of the stars to the creations of human art. Euclid's influence is unforgettable. During the Islamic Golden Age, his books were translated in Baghdad's House of Wisdom. Muslim scientists such as al-Farabi, Ibn al-Haytham, and Nasir al-Din al-Tusi drew new inventions and theories from his principles. These same texts later reached the universities of medieval Europe, where they remained core curriculum for centuries. In the 17th century, when modern science was born, figures like Galileo and Kepler tested their observations against Euclidean principles. In the 19th century, Lobachevsky and Riemann challenged Euclid's 5th postulate and laid the groundwork for non-Euclidean geometry. Those concepts of curved space, ultimately became essential to Einstein's theory of relativity in the 20th century, helping us understand the very fabric of the cosmos. Thus, Euclid's ideas continue to breathe within modern physics and cosmology. Euclid, then, is not merely a teacher of his own time, but a guide for every era. When we design a modern bridge, chart the course of a rocket, or model the universe, we are, in truth, students of that same Greek master. His name rises from the mists of time and shines today as brightly as it did 2,000 years ago, when he taught his pupils in Alexandria the eternal language of lines, angles, and circles.